Okay, so hi everyone. My name is Andrey Melnik. I'm a VP of Data and Solution at Navixy, and today I'm going to talk about how telematics data and telematics itself are evolving into something different, evolving into comprehensive analytics, autonomous systems, and entirely new ways on how we manage assets and how we drive ecosystem for these systems. It's not something which is super futuristic. This is something which is happening right now. Transformation is happening right now, and it looks like we need to be involved in this transformation. Let's deep dive. Before we can start with the speech, I would like to ask you some questions for those who use monitoring systems every day. You don't need to answer that, but you need to think about data and the volume of data, because look at this. How many of alerts did your system generate yesterday? How many of alerts were preceded with? How many risks were detected but not prevented? You see, now we have more and more vehicles connected to the platforms. We have more and more data. For example, modern devices, they can send even up to 25 gigabytes of data every day. The number of sensors are increasing rapidly. And the best question here, are we really prepared for that amount of data? Do we need better dashboard to have modern comprehensive analytics? Or maybe we can think about the system which can react on their own, the intelligence system. For decades, we have like one question which we were focused on. Where is my driver? Where is my vehicle? What's happened yesterday with my driver and vehicle? And tracking was the goal, and visibility was the objective. We have a lot of data in our dashboard and reports. We can definitely say that dashboard and reports are a part of the operational center for the fleet managers. And we can definitely say that entirely industries became measurable. But something has changed. Now we see the data has been exploded. What does it mean? It means that, again, we need to have only one fleet manager who need to deal with such amount of data. Are we ready for that? Not really. And that's the reason why a lot of companies, they start thinking differently. They try to not just have the reactive analytics, but proactive analytics. What they need to have answers. They need to have information, forecasts, planning, everything which will allow them to think about differently. And this is about intelligence, and this is about how we move from the visibility to intelligence. But before we can scale this intelligence entire the enterprises, we need to think about a few challenges and fix these problems. Let me highlight some of them. The first one is about data isolation. What does it mean? It means that we have a lot of data, telematics data, business data, metadata, any kind of thresholds, and we need to take all of them to make the comprehensive analytics. Next is segmentation of data. Again, we can gain this, but what we can do with this just a few amount of data? Is it a full picture? Not really. What we need to think about kind of ecosystem which can take all of this and give us some insights. But not having all of the kind of systems as a intermediate layer, we have, of course, incorporated insights. At Navixy, we went in a different way. We built a comprehensive, unified analytical platform, which is combining together telematics data, business data, metadata, and different layers of data, which will allow you to have a full picture. And then, having this, we can easily say that actually we are ready for the AI, and AI will give us more precise answers, and decision-making process will be more faster and smarter. How it goes? Frankly speaking, we cannot do this in just one step. There should be different layers we need to proceed with, and of course, everything starts with the data itself. Now we are moving to the monitoring analytics events. We have this operational visibility, but what's next? We need to have prescription, predefinition, we need to have forecasts and planning. And here we need to have another one goal. We need to reduce operational exposure. Next is automation and autonomies. What does it mean for us? It means that we expect to have a system which will learn continuously, which can adapt to the environment itself, and which can act on their own independently without the human on the loop. Let me give you some examples, real practical examples we faced with in our practice. First is about trips and anomalies. For example, let's imagine the fleet of 100 vehicles, and let's say they have 10 trips per day for one vehicle. What does it mean for fleet manager? He needs to monitor and check 1,000 of trips. It's a huge number. What if we can give him the system which will just give him suspicion of the trips, anomalies of the trips, and of course it will lead to reduced time he needs to spend for the checking of those trips. Idling time. This is something which is really about the money, because idling is about fuel, fuel is about costs, and here we can identify the risk zones and improve and decrease up to 25 of the time spent for the idling. Driver behavior. Again, this is something which is really impacts the safety and security, and of course downtimes. For example, poor driver behavior could lead to abnormal wear and tear, and of course to the vehicle downtime and brakes. Next phase with regards to the proactive or predictive maintenance. Again, maintenance is something we can gain from the mileage traveled or time traveled, but look at this. What if we can take the usage analytics? What if we look at the DTC codes? What if we can take some more data from our sensors, and then we can predict the maintenance before the incidents can happen? Demand forecasting. Again, let's talk about the, for example, static asset tracking, like diesel generator. And we know definitely that different users, they need different demands on the capacity of diesel generator, right? And you knowing this, having the history in the past, we can forecast what kind of diesel generator we can provide for this particular customer. And ETA, estimation time of arrival, is one of the key metrics for logistics. And of course, people would like to know when the delivery is happening. And that's the reason why we can just take the history of the trips and orders, and based on that, we can apply AI and machine learning to get some more information and insights about that. What is really exciting me is about the big data itself. We just talked about the fleets and vehicles inside of the fleets, but what if we can take the entire number of fleets for the entire city, for example, Mexico City, and having this information, we can think about, for example, traffic jams and how we can dynamically manage this through the traffic lights. Or maybe we can take this data and find out bad roads with broken surface. And of course, it will allow, for example, municipalities to fix these issues prior citizens can highlight those. Let's look, let's move further. And I would like to mention that actually at nowadays we have a lot of companies which are about the automation. They automate their workflows like we did with the IoT logic, where we can use, for example, the flow which triggers the entering or exiting geofence, and we can manage the device itself. But is this really the step way to the autonomous systems? Not really. Why? Because automation means triggering, and triggering means rules which could be defined by entire the human fleet manager or operators or whatever. If we were talking about autonomy, we need to think about how we're gonna take the people out of the loop, out of the decision making, and give this system an ability to react on their own independently, based on their learning, based on the context itself, and based on how they can take into consideration different goals and objectives. And this is a moment where we are moving to these autonomous systems. And again, this is not just about moving from the static asset management system, but it's a moment where we need to decide what was the first. Software? Not really. Application? Not really. It's entire system within software, application, MCP servers, AI, machine modeling, console, any kind of integrations. And let me give you just 5 of maybe 3 examples of how to do this. For example, digital twins. Digital twin is a kind of virtual replica for the vehicle, for the role, or even operation. which you can take and do this benchmarking, which will be used for the comparison of future planning, or personal assistants and agents. Again, this is not something which is will be in the future, because normally we use all these agents and assistants nowadays. It can reduce the operational exposure, it can help you with these administrative routine tasks, and of course it can not only just give you an information, but also it can execute some actions. And AI and machine learning, it's a core. Why? Because we are talking about dynamic system, and we are talking about agile intelligence and the scalability across enterprises. And the question is not about all these systems will be a part of decision-making process. The question is about who is going to shape this future. Thank you very much.